In this particular segment, we'll talk about facility location techniques, and we'll look at three different techniques: factor rating system, also known as the scoring model, center of gravity method, and finally the transportation model. Let's begin with the first one, factor rating system. Let's say you have three different sites that you have narrowed down your choices to, site 1, site 2, site 3, and you have decided the factors which are critical for locating these facilities are labor pool and labor climate, proximity to supplier, wage rate, and so on. And you have to come up with weights, what weights you want to assign to these factors. And in this example, the weights are 0.3, 0.2, 0.15, and so on, and all the weights add up to 1. Now, based on your knowledge of these sites, these locations, these cities, you have to come up with a score for each factor on a scale between 0 and 100. And so in this example, you got site 1, where you decided that labor pool and labor climate, you score the site 1 as 80, whereas site 2, you decided that the weight is 65. It is subjective, but it is based on your knowledge, and so on. Once you have done that, obviously the understanding is 0 is the worst score and 100 is the best score. Next, you calculate weighted score for each site, which means multiply weights times respective scores and add them up. And if you do that, you get a score of 82.05 for site 3, which is the highest, and your decision should be site 3. I'm going to now explain the same technique using Excel spreadsheet. So how to solve the same problem using Excel? Well, I have transferred all the data here. All the factors are listed here. Their respective weights are given here. And these are the scores of site 1, site 2, and site 3, respectively. And what we need to make sure is the weights do add up to 1. So I'm going to just try this out. And I'm going to say sum of these weights, and it should turn out to be 1. If it is not 1, there is a little trick you have to play. I'll explain that in a second. Then we need to figure out the weighted score for each one of them, which is simply multiplying the respective weights and score for each site. And if you did that, you will get sum product. And I'm going to anchor it by hitting F4, and F4 cycles through fixed referencing and mixed referencing. And I want to this time make sure that my columns are anchored. So B should be anchored. That means there should be a $ before B3, and there should be a $ before B9. So F4, it makes it fixed referencing. $ is before 3 and 9. And now this is what I need. And this is going to be just relative referencing, because I'm going to copy the formula over, enter this, and that comes with the score, and copy this over. The beauty is when you do this, this column remains unchanged for each sum product. And based on this, we know that this is the highest score, and site 3 should be your answer. Now, what if the weights did not add up to 1? What will you do in that case? Well, that's not too difficult. I'm going to change some weights so that they don't add up to 1. I'm going to make it 0.1, and I'm going to make this as 0.1 again. And notice the weights don't add up to 1. So you will have to modify the formula here. Click on this and divide it by the sum of the weights. Now please make sure that you anchor it, fixed reference it. F4 makes it $B, $10, which when you copy the formula, the sum of the weights by which you're dividing will remain unchanged. enter, and then copy this formula over. And now, with these new weights, the answer turns out to be side 2. So that's how you deal with situation when your weights don't add up to 1. The second technique is center of gravity technique. This technique is typically used for locating warehouse and distribution centers. Let's begin with an example. Let's say that you have 4 demand centers, Dallas, LA, New York, and Chicago, and the demand there are respectively 1 million, 3 million, 3 million, and 2 million. Obviously, if the demand in LA was more, the distribution center should be located close to LA. If demand in Chicago was 20 million, obviously the distribution center is going to be closer to Chicago. The nice thing is that the weighted center of gravity method does take care of those kinds of requirements. So in this example, what we do is we have these 4 demand centers and their respective demand. The first thing we do is we look at the US map, or the map where you want to locate this, and superimpose a graph paper, and then arbitrarily select an origin, 0, 0, your x coordinate and y coordinate. And once you have done that, you can go and read the coordinates for each of those demand centers. When I did that on this example, using my own origin, I got coordinates for Dallas, LA, New York, and Chicago as 8, 3, 0, 4, 14, 8, and 10, 7. That is x coordinates and y coordinates. Once you have those numbers, you can calculate the center of gravity using the formula which I showed you before, and I'm presenting it here once again. The x coordinates times respective weight, add them up, divide them by sum of the weights, and do the same for y coordinate. And once you do that, you will get the location coordinate for the center of gravity as 7.78 and 5.89. You can go back on the original graph paper and identify where you should locate that center of gravity. Please remember, these are only guidelines. These are not etched in stone. For example, you go there in the location you want, and there happens to be a national monument. You're not going to walk in there with your bulldozer and say, my calculation tells me that I need to locate the warehouse at that location, so I'm going to destroy this and build my distribution center. Obviously not. You will have to find a nearby location, a location where you have easy access to highway and other considerations. This gives you a general guideline as to where you want to locate your warehouse. We'll move on to now Excel application. Now solving the same problem using Excel, you will notice the demand centers, Dallas, LA, New York, and Chicago are listed here. Their respective weights. Demand or weights are given here, x coordinates and y coordinates are given here. You need to figure out the center of gravity. The first thing we will do is we will figure out the sum of the weights, which can be obtained simply by hitting on auto sum. The weights add up to 9. And next, we will calculate the x coordinate using sum product. These numbers, I will anchor them for b, comma, this, and divide it by the weight, and I'm going to F for it, and that becomes my x coordinate, and copy it over, and that gives you the y coordinates. If you don't want that many decimals, let's reduce it, and approximately 7.78 and 5.89 is the center of gravity location. You can go back to the original diagram and locate this point on your original scale, and that should tell you where you should be locating. The final technique that we will look at is transportation method. This particular technique is a special case of linear programming optimization. We will spend a few minutes on this technique. Please understand that we are not going to spend time on learning all the manual technique for doing this kind of problem, because that can be pretty involved and can take a lot of time. So I'll teach you a little bit about some quick and simple way to find a reasonable answer and go from there. So please take a moment and read the next 2 slides. That's an example. Okay, so you read the problem. Please understand that you have to have the PowerPoint handy, because you will be referring to the problem statement back and forth. As I said, we'll talk about a technique known as least cost cell allocation method for transportation problems. This is where we'll find a reasonable answer, but it need not necessarily be the best answer. In many cases it will be, but it's not guaranteed. And I will explain these 3 steps. How do you do this kind of problem by working on this actual example? So the transportation table looks like this. You have demand centers, you have capacity or supply centers, and we'll fill out these tables using the example. So recall the demand centers are LA and New York City, and their respective demands were 800 and 1200. And there are 2 existing supply centers, Atlanta and Tulsa, with their respective demands of 600 and 900. Now the decision is which city you want to build your next supply center. Is it going to be Houston or New Orleans? So let's begin with the first one, Houston. The new plant is going to be in Houston, and the capacity will be 500. Notice the total capacity is 2,000, and so is demand. 800 plus 1200 add up to 2,000. Now if you recall, if to make 1 unit in Atlanta and ship to LA, it costs you $14. Similarly, all other costs have been filled out. Now your objective is to find out what is the best way to provide for these demands from supply centers. And we will use the technique known as least cost cell. So which is the least cost cell? Well, Houston. Houston has $7 per unit to make and ship to New York City. So the cell is Houston to New York City. All right, so allocate the maximum you can to this particular cell. Notice Houston can supply only 500, although the demand in New York City is 1200. So the maximum you can ship from Houston to New York is only 500 because of the capacity constraints. That also means that you have used up all the capacity in Houston. Now, of the remaining cells, which one is the next least cost cell? Well, if you look around, you will notice the next least cost cell happens to be Tulsa to LA. And you populate that by 800, because although you can supply 900 from Tulsa, but demand in LA is only 800. So the maximum you can put in that cell is 800. And you will notice that now you have fulfilled the demand in LA completely. So you can draw a faint line indicating that LA is done. Of the remaining cells where you can possibly allocate next, the next one is Atlanta to New York City, and you can allocate 600, and that leaves you with Tulsa to New York City of 100. And you will notice that horizontally, 0 plus 600, they add up to 600. 800 plus 100 for Tulsa, they add up to 900. Houston to these 2 cities also add up to 0 plus 500, add up to 500. And vertically also they should add up. And that's nice. Okay, so you can calculate now the total cost for this allocation, which is going to be you are shipping 600 quantities from Atlanta to New York City at $11 a piece. You are shipping 800 quantities from Tulsa to LA at $9 a piece, and so on. And you will notice the total cost of this allocation is $18,500. Now recall, that this is with the assumption you are building your new plant in Houston. We will repeat this example with this time New Orleans as your facility location. All right? So please try this problem on your own. You have the PowerPoint handout, so please set up and start attempting to solve this problem. All right. Did you run into a problem here? Yes, you did, because there is a tie between Tulsa, LA and New Orleans, LA. They both cost $9 a piece. How do you break the tie? Well, there are multiple ways. One is by looking at the incremental cost. Notice if you don't ship from Tulsa to LA, you will have to ship those quantities from Tulsa to New York at an incremental cost of $3 versus New Orleans to New York City cost you only $2 incrementally. So you're better off shipping as many quantities from Tulsa to LA. That's one approach. It's a little complicated. Or the second technique is basically you look at the cell which can take the maximum. So if you were only shipping from Tulsa to LA, what is the maximum you can put in that cell? 800. And if you were only shipping from New Orleans to LA, what is the maximum you can put in that cell is 500. So obviously you'll break the tie using Tulsa to LA because that takes the maximum at lower cost. Fortunately, the first technique which I briefly described verbally gives the same answer in this case. That technique, by the way, is known as the Vaughan method. But I'm not going to hold you responsible for that. That's a special technique you can read up on your own. But let's go with the simple technique. Okay, so you allocated 800 from Tulsa to LA, and that fulfills all the demand in LA. Now, you have another tie, and you break the tie by allocating to Atlanta, to New York City, because that takes maximum, and complete the rest of the problem. And you will notice that total cost for this allocation turns out to be $20,500. So, what should be the decision? Basically Houston, because Houston costs $18,500 versus New Orleans will cost you $20,500. That completes our discussion on the third technique. And also, I want to remind you that we went over 3 different techniques.